All right, in this video, we're going to take a look at performing some arithmetic operations with vectors, such as adding and subtracting vectors and multiplying vectors by real numbers. So first up with vector addition, we can add vectors by adding the horizontal components together and then also by adding the vertical components together. So you can think of these as like combining like terms from algebra class where the horizontal components, the numbers in front of the I or the numbers in front of the commas, are like terms, and then the vertical components, the number in front of the J's or the numbers after the commas, could be combined together as like terms. So for instance, let's say we have a vector v at 3, 4 and another vector w at 1, negative 2. So we would combine the horizontal components together, the 3 and the 1, and then combine the vertical components, the 4 and negative 2 together. So if we're adding these two vectors together, vector v plus vector w, we get 3 plus 1 for the horizontal components, and then 4 plus negative 2 for the vertical components, which gives us a result of 4 and 2. Now, from a visual perspective, when we add two vectors together, the second vector, w in this case, picks up where the first vector ends. So here's vector v at 3, 4, and then vector w of 1, negative 2 means that we're going to start from where v ends at 3, 4. We're going to go 1 right and then 2 down, and then this is where we're ultimately going to end up at 4, 2. And when we add vectors together, that's called the resultant vector. So here's vector v plus vector w in purple as the result of adding vector v plus vector w. Now, vector addition is also follows what's known as the parallelogram rule, and in addition to having vector v and then adding vector w to that, it doesn't matter if we reverse the order. So if we look at vector w first, which starting at the origin, we go right 1 and down 2, here's where vector w would be, and then add to that vector v. So notice we didn't change the direction w is pointing and we didn't change its length, so we can go vector w and then add in vector v, and we're going to end up in the exact same place. So vector v plus vector w, much like adding regular real numbers, is the same result as vector w plus vector v. So scalar multiplication, if we multiply our vector by a real number called a scalar, we get a new vector. So here we have a generic run-of-the-mill vector v, not the same vector as the last previous slide. And it's going to have a horizontal component to it and a vertical component to it. And let's start by multiplying that by negative 1, so negative vector v. Well, negative vector v, it's going to be the same length as the original vector, so they're going to have the same magnitude. It's just negative vector v is going to point the opposite direction. So let's say original vector v maybe had coordinates of 5 and 2. Negative vector v is going to have coordinates negative 5, negative 2. So it's just going to make each of the horizontal and vertical components their opposite, which is just going to have the vector pointing the opposite direction. We can also take vector v and double the magnitude. So here we have 2 times vector v, which notice it's pointing the exact same direction as the original vector, but now instead of having just whatever this length would be, now it's double that length. And going back to geometry class with ratios and proportions and scale factors, if we double this vector from the original, we're also going to double the horizontal component, that horizontal length, and the vertical component and the vertical length as well. So if we multiply one side of a triangle by a number such as 2, we got to multiply all the sides of that triangle by a number by that same number. So related to scale factor from geometry class, that's where we get the name scalar. So again, scalar multiplication is going to, in essence, distribute this value to both the horizontal and vertical components. So if we double vector v, we're going to double the horizontal and double the vertical. Vector subtraction can be thought of as adding the opposite. So v minus w, vector v minus vector w, can be thought of as vector v plus negative vector w. So with vector subtraction, we have vector v, And then we're going to take vector w and make it the opposite. So we saw in the last slide how it's going to just flip this vector w around. So now we have v plus negative w, and here's where we end up with v minus w. So we started here and ended here. And we could pick this side up and move it wherever we want, such as long as we don't change the direction or its length, and now we can put it over here. So vector subtraction, if the two vectors share an initial point, then the side opposite, the angle that they make, is the difference between them. So example 2a, we have vector v is 5i plus 4j, and vector w is 6, negative 9. In component form, find each of the following. So vector v plus w, here I have them in bold. I'm going to interchange between the I and j notation and the component form. Again, unless I tell you otherwise, you're free to use whatever form you like. So vector v plus vector w, here I'm doing this one in component form. So 5, 4 plus 6, negative 9. We're going to add the horizontal components and then add the vertical components. So 5 plus 6 for the horizontal, 4 plus negative 9 for the vertical, and we get 11, negative 5 as our answer. For vector v minus vector w, we have 5, 4 minus 6, negative 9. So this time we're going to have to remember to distribute this negative to both the 6 and the negative 9. So for our horizontal component, we're going to have 5 minus 6. And for our vertical component, we're going to have 4 minus a negative 9. So just make sure you distribute the negative to both terms. So 5 minus 6 is negative 1. 4 minus a negative 9 becomes 4 plus 9, or 13. Example 2c, we're going to scale our vector v by a magnitude of 6 by a factor of 6. So take that 5, 4 and multiply each component by 6. So 30 and 24. Or 30i plus 24j, again, it doesn't really matter. All right, and finally, example 2d, we have 2 times vector v plus 4 times vector w. So we're going to scale v by a factor of 2, scale w by a factor of 4, and then just add those results. So 2 times vector v, here I'm going to use the I and j notation. 2 times 5i plus 4j, and then plus 4 times 6i minus 9j. Well, distributing the 2, we get 10i plus 8j. Distributing the 4, we get 24i minus 36j. And now we can combine our I terms as our horizontal components, our I terms as like terms, and our vertical components, or our j terms, as like terms. So 10i plus 24i is 34i. 8j minus 36j is negative 28j. So we get 34i minus 28j, or 34 comma negative 28 in component form. All right, so that about does it for this video. Thank you for watching, and I'll see you next time.